Since we tend to have Thursdays more of a lab day, so I would make sure that you have your Arduino kit and your Mars MIP emulator. We'll be getting into some of the details there on those. Okay, I'll go and get started. Let's go ahead and open up in prayer, and I'll give you a sense of what we're going to be covering today. So, dear Heavenly Father, Lord, I pray that you would be working in each of the students' lives in this course, Lord. I pray that the material that we're covering will be interesting and things that they will be comprehending and be able to see how this is going to be helping them as they move towards their future and their careers that they'd like to get into. Help them with their spiritual formation, Lord, to have the larger context that we can establish by knowing Scripture, by knowing the theological concepts in which we want to be guiding our life by, and give them interesting and creative ways for faith integration. In Jesus' name we pray. Amen. So first of all, I want to say thank you for those that have filled out the survey. I've been taking that information and digesting what people have said. And so the statistic, I still don't have really as a large a statistic as I would like for people to be sharing what is working, what's not, to know if there's any adjustments that needs to be done. I've started to pick up a few things, and so I will be starting to utilize that information to be better informed about how I go about continuing for the rest of the course. But I also want to see if there's any more thoughts that people have, and so I welcome some more feedback from all of you. So Thursdays are more of a focus on lab. So we pretty much finished our digital logic discussion. I will offer it up if anybody has something else that they'd like to be sharing on that in that regard. But I'm going to be moving on in terms of our lab time, focusing on the assembly language programming as well as getting involved with our Arduino kits. And so today, not only just asking if you have your Arduino kit, I want you to pull it out, plug it in, and I wanted to see if we can get a basic program running similar to what I've already showed you, but I will be pulling it up again and trying to get audience participation reviewing that. So let me just highlight a few things here from our charts, because as we get into some of the details of the assembly language program, we're going to be getting into some stuff that will be getting into some of this later area, the instruction sets and how things function in a processor. So I'm just going to highlight a few charts that I've laid out in what I call the greatest hits section. And then we'll be getting into this more later, but just to start to touch on what that's all about. So the format for an x86 architecture, it actually varies in terms of the total number of words that is used. And that is one distinction between what we see between x86 versus what is in a ARM instruction, and the emulator that we're using is an ARM-based emulator. And so everything has a fixed length, 32 bits. And so there's various ways in which this information is utilized for different types of commands. And we're just starting to see that with what we're doing with our assembly language program that we have. And so this is the general things that you can have with a statement. You can have a label, so you can actually have loops. You have the ops code, the mnemonic, you have what it does things on, and you also can have optional comments. And there's a couple different ways that you can be putting in comments, a semicolon, a pound sign. Those are some of the possibilities that are out there. But one of the things I'm going to show you is a tool, another tool that I found, because I know that the Mars emulator is just actually quite good, but it is getting dated. And so I have constantly been looking for ones that are out there that might be a new and improved version. And there really isn't a one for one, hey, we got something now, we're going to switch over to something else. And so I will introduce one thing that I found that will be introducing some of what we're seeing here. And so we'll be getting into this whole idea of pipelining operation. And what that means is that we've talked about this fetch execute, and there's actually another way of thinking about that where you can divide it into 5 or 6 parts of that, that what actually takes place in the execution of an instruction. So that's just another thing I just wanted to introduce for now as we think about what we're doing in assembly language programming. So let's start out with the Mars emulator. So last time we got everybody set up with the Hello World program. And so let me just do a round table here. Everybody have your Mars MIPS emulator up and running on your desktop.
Yes.
You can just do a thumbs up or say yes, go off mute, whatever works best for you. Okay, good. I've seen some thumbs up. Wanted to really make sure that you have that. And so you're going to be doing coding. We actually did programming with Digital Logic was a first, and now we're starting to be doing this for a assembly language, which is focusing on you're actually engaging directly with a processor and telling it what to do. And the CPU is nice, and so it needs to have instructions to make that all happen. And so I showed you a couple examples. I showed you a Hello World example. That's one that I shared with you. And then I will get into a couple other examples that are more complicated and start to be introducing different ways of what you can be doing in this level of programming. So in general, we have with this level of programming, the way this is set up, we have the load commands, we have syscall. We've given an example of what this is. And so a syscall 4 is for printing a string. A syscall 5 is for reading the read and input. So we have these various syscalls that gives us a way to have that engagement with the command line or a file or something like that. This is this particular program gives an example of a loop. And so I'll just run through this. First of all, once you load a program, the first thing you have to do is to assemble it. So that's under the run feature. And so now as we've talked about, we have this translation from what is the way that we think easy to see the lines of code to moving in the direction of what actually is seen for the CPU. And it basically just understands ones and zeros. And that's the thing that we have to translate how we think into how a computer thinks. So let's go ahead and just do a single step on this. And so this is demonstrating a loop. We're going to have some printing and reading. And so let's go ahead and give this a shot. So in a single step mode, first we have this first instruction. And so we're setting up the syscall here. And so this is a more elaborate way of doing that. And so we're going to be printing a string. And so this is, if we go down to the bottom, message 1 is the number of integers. And so we're going to have to be putting in that value. So the first thing that we have is we set it up so we're having the syscall that's going to be printing out a string, and then we're going to have to respond to that. So here is a number of integers. Anybody want to give me a number?
20.
20? Okay, put in 20. Sure that. Since I'm going single step mode, may have to go one more, maybe a couple more to make it so that it's ready to take the input. It's not yet. So we did the first syscall was a printed message, and next it has to have the syscall to actually be ready to take the input. Now we see that the cursor is there. So if I put in 20, now that I put it at the command line, now it has to, this has now been read into memory, and now it has to take that over to the processor so it knows to process that. Let's see if we can track where that is. And so we have the syscall. So here, T0 now has a value of 20 that we put in. And so let's look back what this is. And so we know that this is going to tell us how much we're going to be looping here. So we're adding integers, one all the way up to this, to what the end of the loop is, and we're going up to 20. And so this might take a little while, but I'll try and step through it just to give you an idea. So we have 1. Then we have 2. Total is 3. 1 plus 2 is 3. And then we have 3. 3 plus the total gives us 6. And so we can see how we're moving through this loop. 10. Then we'll go to 15. 21. 28. 36. 45. So I'll just kind of go faster here. So you can see how that is working with a loop. So similar to how we would be doing programming in a higher level language, we can see how this works for an assembly language. And I think we're up to 20. This probably is going to be finishing up here. Okay, we've done that. We've executed the loop. Now it's going to print the results. And so first of all, we'll be doing the same thing we had before, a syscall 4. That's what sets it up that we're going to be doing that print. And we have that. And then we're going to do get ready for an exit. And so it's going to print out the value, the total, the sum. First of all, it has this other string that we have down here, the sum equals. And then so it's a nice way of formatting it. The next thing it's going to do is print out the result. 210. And then it's going to do a clean exit with a call to end the overall execution. Any questions on that? You guys following what we've got there? Let me pull up the chat to see if there's any. Okay. So maybe try and strategize. Maybe I'll just do this for a comment if anybody wants to go off mute or put it in the chat. Anybody have an idea of what you would like to be doing with your assembly language programs? What's related to your overall project plan that you would like to see doing in this area of what we're doing in our development work? Anybody have some thoughts they want to share?
Basically, I'm wondering if we can implement the logic that we set up through the hardware simulator with machine language.
Yeah, that sounds good, Wasim. And maybe just as I always trying to remind people, try and do something that's straightforward and you can add to it. And so having like a simple set of logic gates that you try and implement. So we see here, we've seen some examples, we're doing adding. And so maybe you might want to be doing some logical operations. And for the Mars MIPS, you have a lot of resources that are just right in the program itself. And so you might want to be looking at some logical operations. Bitwise and there could be several possibilities. We're just doing a single bit. And so some of these things may be overkill, but just try and do something that's basic. So here's like a bitwise NOR, a bitwise OR. So NOR, OR, and just begin to try and do some lines of code in that way, and get back to me, and maybe we can talk about that in some of our future Thursdays to see if anybody is getting stuck or has any things that they'd like to go over that. Does that help, Wasim? Maybe give you a plan of action on what you might want to do?
Yeah, that helps. Thank you.
Okay. Anybody else have any thoughts or challenges that you might want to be having us think about as how you're gonna do this part?
For the coding portion, is there a way we can be able to input something that detects motion, or is that kind of going beyond that?
Well, that's actually a good point for us to be thinking about. So what does a CPU do? It's just manipulating ones and zeros in a certain way as it's programmed to do. And what we were talking about on Tuesdays, we were talking about I/O. And one of the things I introduced that maybe you hadn't thought about it, even like a Wi-Fi or Ethernet, that's input and output that has to be dealt with, a keyboard, a mouse, all of that. And so if you have a way of characterizing motion, what it ultimately boils down to, it needs to be translated into a way that the processor can understand it. And that's the big job of what the input and output modules do. They're doing various types of translations to have that happen. I've mentioned that I've been doing some stuff in neuromorphic computing, and that's exactly what goes on. It's like we have our sensors. It's like I'm looking at my screen, trying to engage with you guys. I'm listening to what you're saying, reading the text that's on my screen. All of that is going on, but when it goes to my brain, it's gone through a translation so that it then can be manipulated, processed. I can make decisions on, well, what should I comment on next? You know, David, you brought up a few points in trying to figure out how would we deal with motion. And so what is motion? And so you can think of motion as velocity. Maybe you want to be bringing in acceleration. So it's movement per unit time, like meters per second. And so those are the kind of things that then start to play out, that I have to come up with the sense of what I'm trying to accomplish, figure out what algorithmically that means, and then figure out how to do some coding. So that is actually more difficult than what Wasim was saying about just trying to directly go over to what would be done with the digital logic ones and zeros that we're coming up with an aggregate. That's actually pretty interesting. And so maybe what you could just stipulate that for after this translation is what's going to the CPU, you can just say that it's motion. Let's say it's a velocity. So let's say it's 1 meter per second. So it's either you're putting in 1, 5, or 10. Maybe those are the three things that you're going to use as a proof, as a rough sense of what you would be saying. Okay, you're just trying to do that detection. If it's 1, that means it's fine. If it's 5, maybe we need to, whatever analogy you wanted to have, maybe put on the brakes. And 10, it's not only that, but we need to engage the emergency brake. Whatever you would want to be thinking about, but trying to come up with that logic. Does that help, David?
Yes, thank you.
Okay. So that's another bit of thinking about the Mars MIP emulator. And so why don't we go ahead and be spending some time in our classes to see where you're at. If you want to be sharing your code, please feel free to do that. But let me just introduce another program that I know that the Mars emulator is getting towards the end of its life. It is not recompiled to a more current version of Java, and so that has some challenges. But this is a program that has a little bit interesting history that I just was looking into. And so this is something called edu MIPS 64, and it's actually compiled against Java version 17 versus Java version 8, which is what the Mars program is done. But it has some interesting features, but it is a little bit different. Let's kind of, and so this is their manual. It's actually, was designed by some Italian students, and it has continued to be maintained. And so it's, like I said, it's I think back in 2016 is when it was written, and it's still each year they update it to the latest version of Java, and also do some additional functionality. So what we have with the way that the Mars presentation is, it really is an IDE. So you have the main focus is the coding window. We have a nice way that we can be seeing the registers. We have this window. We can go to another window, which gives us more information. We can be looking at the execute window. And let's contrast this with this other one. And if people would like to try this, that's fine. But let me just give you a sense of what I'm doing, just to be on the safe side. I've told you that I use a product from Microsoft called Microsoft Remote Desktop. And so on my Mac, I can go ahead and remote login using RDC, an RDC connection to another computer. So I'll show you that in a minute. I've already done that with my Microsoft Surface. This is a Linux virtual machine that I'm using VirtualBox on my computer. I have a Mac that's based on a x86 architecture. I haven't bought the new one that has gone to the Apple Silicon. And so this, as a result, is still an application I can use. If you have an Apple Silicon Mac, you're going to have to be using something like Parallels, which is ahead of the game in doing some of this. But this is an open source way of doing virtual machines. I actually got it to work on Windows 11 in a virtual machine, but it has a lot of more resources that it takes. And so I streamline it into Linux, and a version of Linux that I use if I need to have a desktop experience is Linux Mint. And so that's what I have here. So this is opening this program, and I'll show you a very basic program, but there's a couple things that we're seeing is now we see the registers. So we saw that type of things that were there. We can see some representation of the memory. That's what's listed here. Also, so this is for the code, the lines of code in a program, and when it's been translated into bit representation, we have access to the data, and we have this kind of a rendering of what it would be looking like with a the type of throughput that we have in a pipeline architecture. And this is a real big focus for what is going on with a MIPS type of process using the ARM methodology. And here we get a chance to have a window that gives us a sense of what's happening with commands. And let me just run a very simple program, the most simple one I could find. And there is a slightly different syntax between this and what we see with what the Mars does. And let me go ahead and open up this the source code for this. So unfortunately, this one doesn't have an integrated IDE in the sense of what we've been using. So that is a distinction. And so you would have to have a separate window to do this. But this is basically just trying to do a very simple call, a call 0, syscall 0. And we notice how we have this, that the way that we were doing this with the Mars program, it has a slightly different syntax, that you load up which syscall you're going to do, and then you do a syscall without any things added to the lines of code there. Another thing that's a distinction is for the comments. For the Mars emulator, you can use a £. For this one, you have to be using a semicolon. But we'll come back to this, but I just wanted to introduce this at a high level. And so I'm going to, let me just try run it real time, and then I'll do single step. I've been doing this single step up to this point. So let me see what happens here. So that went pretty fast. And so that's hard to follow, but let's go ahead and reopen that. And so we see there's like these different acronyms that come up. We're going to get into this in more detail, but you're going to see this kind of tracking of what's happening as a command is actually executed through this pipeline. And so let me just do one step at a time. So here we have this. And so if I wanted to look up what that command stands for, there's a manual that you can download as a PDF, or if anybody speaks Italian, of course, you could be doing it that way. And so I'm just going to walk through running this. And so this is a add type of command. And so we load that. And we're going to see how each step we're progressing in this pipeline. And so here we have this instruction 1, and it takes 2, 4, 6 clock cycles for it actually to complete. And so this is assuming if there's no looping. And so this is how we would be executing through 9 instructions. It would take 14 clock cycles to complete that. And we're going to be getting into this in more details. But since we're getting exposed to this now with some of our assembly language work, I wanted to just do a precursor for that. And so we can just see how we're stepping through that. And this is giving us an indication. It lights up different parts of this pipeline to give us a sense of what's going on. So this is a pretty simple program, and so it doesn't do that much, but at least wanted to give you just an idea of another rendering of what it's like for doing assembly language. And this is another thing that was developed by students just like you, and with faculty support. And maybe this might be a good one for for us to be thinking about a little bit more in the future. During the summer, I made a decision to keep using the Mars emulator, but something like this might be what I'll be using next time. But for now, I didn't change that. And so if people want to give me any comments, if you want to try and do a hybrid, maybe we can consider that. But still, this doesn't quite have all the benefits of an IDE, but it's so far close to the Mars type of capability. This seems like it might be a useful thing to consider. So any questions on a little bit more discussion on the Mars, the assembly language programming, going through another example that does looping. We have engagement with the command line, printing things out, getting an input and then processing that input to finally getting a result and having a clean exit. Okay, well, let's move to the next part. And so this is going to be some audience participation. And the degree of participation that I want at the moment is I want you all to pull out your Arduino kit. And I want you to plug in through your USB, your basic Arduino module. And we're going to actually go through the steps of actually getting you to communicate with your Arduino module. So let's why don't you pull that out and let's go and work through that together as a class. So I have one plugged in.
Is the module the breadboard?
So I told you before that this is a reduced size version. It's called a Nano. I want you to be pulling out your Arduino Uno with your USB cable, and you can be plugging your USB cable into your computer. Now with my Mac, I have to do an adapter from a USB-A to a USB-C. So if this is the first time that you plug this in, let's try it and walk through that together to give you a sense of how to make that work. So why don't everybody just give me some thumbs up when you have your Arduino kit out. You're gonna have to launch your Arduino app. If you don't have that installed, make sure that you go and get this put in. And so you want to make sure that you have the Arduino IDE. So if you have a Mac or a PC, actually, I don't know if you can get it from the App Store. If somebody wants to try that, if you actually haven't installed already, please let me know. So just start to give me some thumbs ups or let me know that you have this. And if you need me to go through some more detailed steps of having to get this up and running, please give me that. Okay, Kyle, good. Josiah's downloading, good. Okay, thanks, David. David's getting his. Enzo was getting it. Since our project work is like 50% of what we do for our course, I wanted to make sure that we use some of our time together to help you get to a point where you're having a sense of success and making progress. And so this is the second and third projects. And so everybody now has the Mars emulator up and running. there's a sample program I've given you all with the Hello World, so you can begin thinking about that. You could actually take that and start to modify it a little bit, maybe adding a few lines of code. So keep a pristine version of the original, and then start to create another one that's of your own making and work with that. Okay, while people are doing that, let me just remind you some of the next steps here. So you just want to have the bare Arduino Uno hooked up to a USB to your computer. And so, and if the first time that you open up the IDE, you won't get something like this. You'll just get a blank, something like this. And this is what you'll get as a default sketch that they call it. And so there's two main sections, the setup. And so this is where you configure things. And then you have the loop where you actually do the execution, engaging in this cyber physical environment. So what I'm doing here is I just opened, I got the examples, and then I went under basics. And I just did the analog read serial. And so this is something I showed you before, but now instead of just having me show it, I want you actually to have the getting some firsthand experience of you actually doing that with your computer. So give me a sense where people are at with doing these next steps. Any thumbs up or comments? People are downloading. Do you have your Arduino kits with you?
I'm opening mine right now.
Okay, good.
I just plugged in the module. How do I select the oh, never
Okay.
mind, I got it. I got it.
Yeah, let's do that next. And so the next thing that you have to do, now for you, it should default to the Arduino Uno. Now, remember that I think everybody is familiar with open source. Well, there's open source software, there's open source hardware. So Arduino has made all of its hardware open source. And so even you may not actually have an Arduino brand, but something else. But effectively, they're made to be the same. So you're going to be clicking on this Arduino Uno. Okay, I have a Nano, so that's reasons what it's like that. I don't think you'll have to deal with this processor, but then you have to define the port. And so if you have the drivers, everything that you need, and if you're just using the basic Arduino Uno, it should be fine. You'll see a bold here port. It'll say COM something. So mine says COM5. So the first thing I have to do is to click on the COM5. Okay, now it's configured. It knows how to communicate with the Arduino unit. Now, we talked about I/O. This is a serial port. And so now I can get this board information. And so what you'll get something like this. And in one way, it doesn't matter what it says, but this is a way of giving you a sanity check that your computer is now directly engaged with your Arduino Uno module. Okay. So let me know if folks got this to work. Thumbs up, or if you have some issues, let me know and we'll go over it. Maybe I'll just at random. Avery, did you get this to work? Okay, good. Riley, how's it working for you?
Yeah, it looks good.
Okay, good. Anybody still having challenges? If you have, feel free to let me know. If you want to have me spend some time with you at the end of class, I can also do that. But so far, I haven't heard any negative responses. And so I'll just go to the next step. So you had that blank one if you, when you first open up, and so just going back, go to File, Examples, Basic, Analog Read Serial, and that's what I have here. So once you've got that loaded, we've verified that we're connected to the Arduino. And so what you want to do is click on this arrow, and then you want to click the upload. And if everything's go fine, it'll just show this green thing. It's loading it up to the Arduino unit. And you'll get a little bit of information here on the bottom, giving you some information about its capability. It says the maximum memory here is 2K, 2.2048 bytes, but it worked. Okay, and so now what is, we actually haven't done anything, but we can start to be looking at what is actually taking place with two things. Is first of all, I'll do the serial monitor. So under tools, you go under serial monitor. And what you'll see, you'll just see a bunch of numbers showing up. Has anybody heard the term an analog to digital converter, ADC? It's for those that are on the engineering side, maybe that's something you've heard of, but basically there isn't anything on this pin. And so basically it's just reading in noise. And so it's digitizing that and giving us a result. So this is one of the ways that this is going to that COM5 port that I told you, and it's working. So we get a chance to see how that works. And so this is one of the ways that you can have a display. The one I showed earlier, it was actually sharing a message. Was showing a communication, an RF communication between two Arduino modules. So this is one way I can be showing this. But so there is the serial monitor, and then there's a serial plotter. And so this has the advantage that if I wanted to be seeing things in a graph, and so David mentioned like what he was thinking about how we was going to do assembly language program for trying to sense velocity or something like this. This might give you an example that would be a little bit easier for you to comprehend that information and apply. So it's kind of has some periodicity here, but there's nothing going on that input as of yet, but it gives you a sense of what it would be like when you actually hook something up for real. And so let me, people give me some feedback. Did you successfully get these graphs or text coming out, those numbers coming with your Arduino kit? Anybody thumbs up? Did you guys get that to work?
I'm having an issue with it.
Okay, why don't
Same.
you give us a little sense of what's going on, and we'll back up, and because I'm sure other people will have that same kind of a issue.
When I upload it, I get like the same output that you got, where it's like Sketch uses so many bytes and
Yeah.
all that. But then after it says that, then I get an error that there's no device found, and then an uploading error.
Okay, what that means is you need to go back to tools, make sure that you select the Arduino Uno. Probably don't have to change this. And then you need to make sure that you have this COM port. You need to select the COM port. This is something that it won't do automatically. So go under tools, port,
Mhm.
and let me know if you're seeing this or not.
Yeah.
Okay, select that. And then after that, go ahead and go to the get board information. And let me know if you get this this return back from the board. This is giving you some of the serial number information from the board that reports back.
Yeah, I have that.
Okay, now go and do the upload. And let me know if you get an error message. You shouldn't get an error message this time. I'm predicting.
it compiled and everything, but then it gave me a uploading error.
It gave you an error. You want